My name is Andreia Carvalho, and I'm a training officer at Mercator International, and I'll be your host for today's session. Before we start, I'll give you some guidelines for our session. We are on Zoom. You can use the chat for small talk, to interact between you guys, to ask us questions related to maybe some sort of problem technicality. But for questions specific for the workshop or to any of our speakers, please use Slido. You can access Slido on slido.com, and you can use this code that you see on the screen, or you can, we will share also the direct link to our Slido session. Please use Slido as much as you can for the questions. We will try also to copy paste some of the questions you put on the chat if that happens. And we'll also try to answer as many questions as we can during our session, although we are a little bit limited according to the presentations. We'll do our best. About the recordings of today's and yesterday's session, they will be available on our YouTube channel. So no worries if you cannot follow today, or if you missed yesterday's session, they will be available in WEkEO YouTube channel. And as for the presentations, you might have received already the presentations from yesterday's session, and some the tutorials we will be seeing today. You should have received it as well in your email, and any other resources you will be receiving today or later on, also via email. And today we will have three speakers. We will have Bina, who's going to show us how to access the WEkEO viewer, how to download the WEkEO data, and other interesting things related to the viewer. He's a user support manager at Mercator International, and he will be here to show you all of that. Then we will have Alexandre Homerin and Daria Andrievskaia from Noveltis. They will be showing us very interesting exercises related to the topic, coastal studies, and what we can do in Jupyter Notebooks and in QGIS, the software QGIS. So without further ado, we will start with our first speaker of the day, David Bina.
Hi.
Hello, welcome.
Hello. Thank you.
The floor is yours.
So hello everyone. My name is David Bina, and as Andrea said, I'm working at the WEkEO user support. So here I am on the WEkEO homepage at wekeo.eu, and I will show you how we can visualize data on the data viewer and also download data from this tool. So here in the header, I can click on data, and it will open the data viewer. By default, there are two layers displayed. There is this Copernicus Land Vegetation Index and the Copernicus Marine Seawater Velocity. When you are on the tool, you can first zoom in and zoom out by scrolling with your mouse. I will try to do it slowly because I know that the video can lag a little bit for you. So for example, here I am zooming in on the Europe area. You can also grab the map to move left and right. At the bottom, you have the timeline, so you can choose another date. When you have some 3D variable displayed, like here the seawater velocity, there is some depth level. You can also here at the bottom right change the depth. So for example, if I go around 2000 meters, we start to see the bathymetry. Okay, so let me go back to the surface. So now here on the layers Canva, on top left, you can click on this plus icon to open the WEkEO catalog. So as you will see, there are more than 400 datasets. Here on the right, you have all the datasets available. It could happen that the dataset is not actually visible on the map, but you can still download it afterwards. So you have the choice. You can either scroll from top to the bottom, but I strongly advise you to use the filters on the left. You can either search, enter a word in the free textual bar, or use the different filters. So for example, for the example of today, I will choose the vegetation phenology and productivity. So for example, I could simply type VPP, and you can see that there are only 5 datasets left, and I will take one of these two. But just to show you, I will reset the filters just to show you a bit the sections. You have the featured datasets. You can add some datasets to your favorites once you are logged in. Then you have the different Copernicus services, different platforms, and for example, the Sentinels. The sensor section is collapsed by default, so you have to click on it to develop it. So for example, you can search ORCHI data, etc. Then you can select the data you're looking for by the area, the time, and different tags. So for example, because I know that the dataset I want to add to the layers is Copernicus Land 1, I can click on CLMS for Copernicus Land Monitoring Service. And then in the tags, sorry, I try to don't scroll too much. I can click here on vegetation. I can see that there are 8 datasets when I select this filter. Okay, so I find back the datasets I have seen before. Let's take this one, the last one. I can either click on Add to Map to add a variable on the map, or before I can click on Details to have the details of the product. So it opens this description page. On the top left, we have a thumbnail showing where the data the coverage of the data, and at the bottom, the geographical extent. Then in the abstract, you have a description of the product, which tells us what we will find in the product. And then we have other informations, like the dataset ID, which can be useful when we want to download the data by script, for example. So now I click on Add to Map, and I see here all the variables contained in this dataset. So let's say I will add the total productivity season 1, for example. I can click on Add to Map here, and then you don't need to necessarily go to the top and click on the cross to close this window. You can click anywhere elsewhere out of this window, it will close it. Okay, so now we can see that I have added this product. You can hide the dataset by clicking on the icon like here. And because I have 2 vegetation products, I will simply remove this one by clicking on the cross. So let me zoom in a little bit more to show you the customization buttons here. Okay, so on the left, it's the download button, but I will show you just after how we download data from the viewer. The I button simply opens the description page once again. This button is quite useful. It allows us to choose another variable without having to open the catalog again and search for our product, etc. We can simply click on this button, and we have all the variables contained in this dataset. So for example, if I open the second one here, I can choose the seawater salinity, and we see that it is automatically updated on the viewer. But let me take back the seawater velocity because I want to show something else, the vectors feature. Then this cog icon is quite recent. I mean, before the opacity wasn't played like this. So we have this opacity slider to play with the opacity, which can be useful when we want to compare several variables within the same area, for example. And what is quite recent is this. It is that we can choose another color map than the color map taken by default. So, for example, I can take the solar one, the thermal one, etc. So I just let it load maybe another color to see it better. Okay, so now it's purple. We can see that I have changed the color map. But let me go back to the default one. Okay, now I can click on the log button to see the variable in a log scale. And also we can click on the show vectors to show the vectors when appropriate. So for example, here it's the seawater velocity. So if I zoom a little bit, here I don't know if it's me, my connection, or the viewer, but it's having a hard time to load the data. I will wait a little bit more, otherwise the demo won't be really clear. But okay, let me click still on the arrow button. We can clearly see that arrows have appeared. And the thing is that if I continue to zoom in, I will zoom in a little bit more. We can see that the arrows are automatically updated, the scale accordingly to the zoom level. Okay, so I hope you can see it just like me on my screen. So not only we have the color showing the amplitude of the variable, but now we can also see the directions of the seawater velocity here. Okay, so now I will zoom out back again over the Europe area, and I will hide this dataset, which was the one by default. I will focus now on the object on the bottom right here. So we have the locate functionality. It allows you to place some points on the map. If I press on my escape key on my keyboard, I can unselect the locate functionality. You can copy the coordinates by clicking on this button. Then you have the measure object, which allows to measure distance between 2 points. And once again, you can click on this button to copy the coordinates. You can click on the cross to remove the object on the viewer. Then you have the set AOI functionality, which allows to draw a bounding box. And afterwards, we will and we can download the data within this area. So it is quite useful. And to finish with these bottom objects, you have here the settings, where you can uncheck the base map. So if I close the window and zoom out, we can see that I have unchecked the base map, and also the coastline and reference feature, so the continents, river, etc. I will check the checkbox once again. Here you can change the units and have the credits on WEkEO. Okay, so now I will show you how we can download data from the viewer directly. Just as a note, as you can see, I am not logged in already. So we can visualize data without being logged in. But to download data, if I click on the button, it will ask me to sign in. So it is completely free to create a WEkEO account. I will sign in with my account, and I will be able to download data. Okay, so now I have these download parameters. So first we have the bounding box, the geographical area where I want to download the data. I can enter the coordinates manually, or I can click on copy AOI from map. So this is the bounding box I have drawn just before. Same for the temporal interval. You can pick a date here. So for example, the 2020, sorry, and click on copy from layer. So because it is a yearly data, it depends on where we are. So let me go to April. I click on copy from layer. So it shows the 1st January 2020 because it is a yearly data set. And if I go to 2021 and click on copy from layer, okay, it will basically download 1 year of data. Or you can type the time interval manually. Then you will see different download parameters depending on the dataset and variable you have selected. So here I have several ones, but they are not mandatory because if the parameters are mandatory, there is a red asterisk like here. So because they are not mandatory, I will let it like that. And then we have 2 buttons. You have the show API requests, which allows to download data via the package called harmonized data access. You have documentation, but this is not the purpose of this presentation. But just to show you, you have the corresponding request to download data by script, and you can copy this request with this button. And the easiest way to download data is simply to click on request data by clicking on this button, and on monitor request. It will open the jobs tab that is here on the same Canva. As you can see, we have the history of the jobs I have done in the past. And just as a reminder or just a note, these jobs stay are reset every 7 days. So you can retrieve back your past jobs, but just for 1 week. Once the job is completed, you can click on this button, which in fact opens the API request once again, or you can click on this folder icon, and we can see that for this specific area and the time interval, I have 87 results. So it corresponds to all these items. I can click on each of these items on order and then on this download button. And here you can see that the download is starting and is now completed. We know that it is not really convenient to download all the items by clicking one by one on each of them. So we are actually working on a feature to download all of them by once, at a glance. But as I said before, you can use the HDA, so the Harmonized Data Access Python package, to download this item just with one line of command. But this is the purpose of the next presentation. If you have any feedback to share with us, the WEkEO user support, or any question, you can click on this button. It will open the chatbot. On this chatbot, you can send us a message by clicking here on send us a message, and we will answer to you. Also, you can search for information here. As Cedric shown you yesterday, or if because maybe you are watching this video later, I will just remind you how you can search an article in your help center. You can click here on the header on support. I will open in a new page, and here this square help center is our help center. So for example, if I'm looking information on how to download WEkEO data, I can type download, and here you will find on this article how to download WEkEO data. You will find all the information on how to download data, whether from the viewer, like I've just shown you now, or how to download data by script with the HDA, the Harmonized Data Access API. So this is the Help Center. And why I was showing this is because these articles and this Help Center is the same in this chatbot. So for example, if I click on search for help, here, if I type once again download, normally I will find the same articles. Here, how to download WEkEO data, and it will open this article in this chatbot. So it is quite convenient. So you can search for information here, and if you don't find the answer, feel free to send us a message. We will be glad to help you, of course. So I think it's okay for me, and I will try to answer your question.
Thank you, David. That was very nice. Are the datasets available updated in real time on the platform?
It's not really real time. If I'm not mistaken, the datasets are there is a synchronization once or twice per day. So if you are interested in a daily dataset, I'm not sure about the hour, so I don't want to say something wrong, but please keep in mind that it is once per day. I prefer to say this. So it is not really real time, but if it's not the day where you're looking to your data, maybe it will be the day after.
Daily, then. Yeah. Okay. Thank you. And then I think the other questions are more general about. There were a few questions about whether the sessions would be recorded and where they are going to be available. They will be recorded and they will be available on the WEkEO DS YouTube channel. We can share the link down below, but you just type WEkEO DIS and you will find it quite easily. That was very nice. Thank you, David. I think we don't have any more questions for the moment. Maybe later on they will
Okay,
come.
feel free to contact us.
We will stay around. Okay. Yes, and also feel free to contact the user support for sure.
Yeah.
And now we'll carry on to our exercises. We will welcome our first, trainer, Alexandre Homerin, Noveltis. He will show us a very interesting exercise on coastal erosion on the east coast of the United Kingdom. And the floor is yours whenever you want, Alexandre.
Thank you, Andrea. Hello, everyone. So I'm Alexandre Homerin from Noveltis, and I'm going to show you how to manipulate satellite data with Python in the frame of coastal studies. I'm going to share my screen and we'll start. In this training, we are going to work in the WEkEO Jupyter environment. So to find it, you can just go to the WEkEO homepage and click on this icon here, which will redirect you to the Jupyter Lab environment of WEkEO. It takes some time to start up, and then you will be in the environment and you will be able to open the notebook for the training. I have a page already open here, so this is what I'm going to use. So for the Coastal Studies WEkEO training, we've chosen to study use case on coastal erosion, which is an issue that is growing more and more concerning today. Because it has many factors, but of course, human activities in the last decades have amplified the phenomenon because the sea level rise, and this is one of the major drivers of coastal erosion, for example. And of course, it has many consequences on ecosystems and even on human life. Here in this introduction is a dramatic example of what the consequences of erosion can lead to. So this is a beach in England, in the north of England. And this is the region we're going to study in this training. So we are going to work with Python, and here is a brief overview of the libraries that we are going to use in this training. So if you're already familiar with Python, you're probably also already familiar with the NumPy library, which contains a lot of essential functions for scientific calculations. We're going to open datasets with Xarray, which is also very useful to open scientific datasets. Matplotlib and Cartopy will be used to plot data, to have visualization of the data. GeoPandas and Rasterio will be very useful to work with geographic and satellite images. So you will see in the next sections how we use it. And finally, we will do a lot of image processing, and scikit-image is a great package in Python to do this. So in this section, we import all the libraries I have mentioned before. So we execute the cell, simple. And the main dataset that we're going to use is Sentinel-2 images. So this is available on WEkEO with this ID. So it can be opened in the data viewer as David has shown you in the previous presentation. Here, we're going to actually study coastal erosion by comparing two images 6 years apart on a specific location and see if the coastline has moved a lot or not. So if you're not familiar with Sentinel-2, so it's a European satellite, pair of satellite actually, that takes image of the Earth's surface. It has a revisit time of 5 days, so it's very practical to study the evolution of phenomenon because we have one new image every 5 days at the same location. It has a 10 meters resolution and many spectral bands. And in our case, we're only going to use the blue, green, and red and near infrared spectral bands to study our coastal erosion. So David has shown you how to retrieve data from the WEkEO viewer. It's a quick look at how to retrieve data from Python. Actually, so if you remember the presentation about the data viewer, you can see that when you do a job, when you send a job, you can, so it's an old job, so I don't have the request now, but you can click on this icon to display the actual request that you made for the data. And if you copy paste it in a text file like this, for example, so it looks like this, you can send this in Python and directly download the data from Python. So here's just a quick example. And here you use the HGI library that's provided in with the WEkEO environment. So this is my request. So we can see that it's the Sentinel-2 dataset. And here I'm just aiming at a specific image. So this is the ID of the image. And here I'm asking the WEkEO server for this request, and it should yield exactly one result, which is the image I'm looking for. And then you only have to execute this cell to actually download your search result. In my case, it appears here, and then you just have to unzip this file with this cell. So here it's already done, so I'm not going to execute it. So we have an image from 2023 and an image from 2017. Yes, we have one image from 2023 and one image from 2017. And we're going to compare the two at a specific location, which will be the town of Hemsby in Norfolk, England. So which is the town from which the introduction image was taken. So it suffers a lot from coastal erosion. So this is one of the places where we should see the most significant results. So in this cell, I'm just going to show you a first observation of the location that we've chosen to study. So with this cell, we're just going to simply draw a rectangle around the area of interest, which is here. We're going to study this beach here. And now we're going to open the two Sentinel-2 images with the library Rasterio that I've mentioned in the introduction. So here I'm just aiming for each spectral band separately. So from 2017, we have the red, the green, the blue, and the near infrared, and same thing for 2023. And we will be opening all of them and storing them in separate variables. So I think this should take, oh, okay, I thought this would take some time, but it executed quickly. And in this cell, we just plot the two images to see what we are dealing with in this training. So this is the coast in 2017, and this is the coast in 2023. And as we can see, the coastline, so I must precise that we have chosen images with the help of a tide model to make sure that the tide signal was similar at the two dates. So the change in coastline cannot be attributed to the tide. That would be too bad. And so we can see that the coastline has changed. We can see that there is probably less sandy beach in 2023, and probably even less greener areas here if we compare exactly. But at this stage, it is just qualitative appreciation, and we're going to try to highlight the erosion more precisely in the next sections. So in this section number 5, this is a quick look at wave data because waves are one of the primary drivers of coastal erosion. And just for the sake of manipulating wave datasets, we're going to do this section to show you another way of another type of data that you can deal with in Python in WEkEO. So this is another dataset of waves. We're going to go back to the images later. This is a dataset of waves from the Copernicus Marine Service, focused on the Northwest European shelf. So, of course, our area of interest is perfectly included in this dataset. So we have downloaded the dataset here in the data folder of the training folder. Of course, if you want more information on the dataset, you can always either visit the WEkEO viewer dedicated page, or even to go even further, the Copernicus Marine Service dedicated page, and you'll have plenty of documentation to learn more about the specific dataset that we're using in this training. So this is where we use the X-array library that I've talked to you about in the introduction. And this is what the dataset looks like once we open it. So this is a NetCDF dataset. So of course it has a different aspect than satellite images. So what we have here is that we have a dataset with geographical coordinates, latitude and longitude, and also temporal coordinates. We can see here, for example, that we have taken a data set that goes from 2017 to 2023. In this icon, you can have the details of the variable that you are studying. And this is a 3-hourly data set. So we have one value every 3 hours. And for waves, it's quite a convenient temporal resolution. And here are our main data variables. And here we've only, to keep things simple, we've only chosen the significant wave height of the waves. This is just to have a quick look at time series. So here are a few basic data manipulation that you can do with X-array and NetCDF datasets. So if you want to select a specific variable, you can just write it like this under brackets after the name of your dataset. And for example, here I'm only looking at the time coordinates. And one of the most common things that you want to do with a dataset is to subset it, is to select specific parts of it. For example, here in this cell, it selects a specific date in the dataset. So see, for example, here I only have one date left in my dataset that I'm displaying here. And this is the one that I've written here. So the 6th of April, 2019 at 6 p.m. And here I've selected a date that was actually in the dataset, but if I don't know exactly what are the dates in my dataset, I can use this argument, nearest. That way, it will select the closest date to the date that I'm specifying here. So for example, here, the closest date to the 6th of April at 10 a.m. is 6th of April at 9 a.m. Because 10 a.m. is not in this dataset. So if I don't use this argument, this will yield probably an error. So this is why this is important. And if you don't want to select by precise date, but if you want to select, for example, only the 4th value of a dataset, you can select a date from its index. So here, by writing 3 under brackets, I'm selecting the 4th date because it starts at 0. The indexing starts at 0. And this is it, 2017 at 9 a.m. So this makes sense. And finally, probably one of the most convenient functions is the slice method, because it allows you to select a range of dates. So it allows you to select a specific periods. For example, here I'm selecting the years 2018, 2019. So I just select from January 2019 to the 31st of December 2019, and I should have my 2 years of data. So here my first date is 2018, 1st of January at midnight, and my last date is 2019, 31st of December at 9 p.m. And one last thing we're going to do with wave data before going back to coastal erosion and the Sentinel-2 images is to plot simple graphs. So here I can plot a simple map near the region that we're studying of the significant wave height at a specific date. So here I'm going to plot the wave height in 2020, 1st of October at 9 p.m. and see what it looks like. So this is the area that we have restricted the dataset to using the slicing and according to the longitudes and latitudes, and this is what we get. And one last thing we're going to do is to see the evolution of the wave time series over the whole region over the last 6 years of data that we have selected in this training. So this is what we're going to do in this cell. So we're going to perform the spatial average along latitude and longitude to have only the average over the whole region over the 6 years from 2017 to 2023. And if we execute this, we plot the graph from 2018 to 17 to 2023 of the significant wave height around the coastal erosion, one of the factors of coastal erosion. Now we're going back to the Sentinel-2 images. So as we remember, we have one from 2017 and one from 2023, and we're going to compare them. And we're going to show you a simple way to extract the shoreline of the two images and compare them. So to do this, we're going to compute the normalized different water index of each image, which is an index that enable us to differentiate between land and water. This index is calculated with Sentinel-2 by doing the normalized difference between the near infrared and the green band. So this is the calculation here, and here is a reminder of the different spectral bands that are available in Sentinel-2, and those are the 4 that we are using, so blue, green, red, and near infrared, band 8. So we'll compute the NDWI for the 2 dates, and we plot them. So here we see that we have a clear difference between water and land. Here there is a cloud that is a kind of inconvenience, but we'll have to deal with it. But this is one of the difficulties of working with satellite images. You don't always have control on whether, you never have control on whether there are clouds or not on the image, but we'll manage. So now that we're going to apply a threshold to the two indexes, and this will enable us to separate water from land. So I'm doing that here. I'm doing a simple threshold at 0 because this is between -1 and 1, and here thresholding at 0 seems enough to well differentiate. We just perform a morphological filtering to clean the dataset. If we don't, we'll have many artifacts in the image. This will lead to noise in the shoreline extraction, so we don't want that. So this is what we do here. We perform what is called an opening. And after this operation, we have these two results. So we can see that the cloud here produced a quite big artifact, but we're going to manage that. So now that we have basically a binary image composed of only zeros and ones, and we're going to extract the shoreline by simply computing the borders between the zeros and the ones. So for this image, it will be quite simple because there is only like one object to segment. It's going to be just a little bit trickier because we will extract the contours of this object, but also the contours of the rest of the cloud and maybe the little artifacts here. So, and this is what we do here, the extraction of the contour using the scikit image library. So to give you a brief explanation of what the Python lines do here. So here is the contour extraction, as I said. In 2023, there is only one object, but only one contour object is extracted. But for this one, the 2017, as I said, many contour objects will be extracted. And so here, I'm only selecting the first one, which happens to be the contour of the big object. So I'm only also selecting the first one of the 2023, but this is easy because the first one is the only one. And one thing I do here is that I erase the edges of the image, because here, when I extract the contour, I extract, of course, the shoreline here, but also everything that's at the edge of the image. So I'm just cutting the edges to only have the shoreline left. This is why I exclude the last 5 rows of the image, the first 5 rows, and the last 10 columns of the image for both contours. And finally, I apply a Gaussian filter on all the contours to smooth them and have a smooth shoreline. And when I do all this, this is what I get. So here is the 2017 image with the 2017 shoreline in red and the 2023 shoreline in cyan. So we can see that there is quite a difference, but at this stage, this is still only well, a visual observation. And in the last section, we're going to try to go further and to quantify the distance of erosion between 2023 and 2017. So what we're going to do here, so one problem that we have to do that is, for now, the contour points of the shorelines do not have geographical coordinates. They are only coordinates with regard to the image, row number and column number. What we want to have is for each point of the shoreline have a latitude and a longitude. The question is, how are we going to do this? We're going to use what is called a transform model. I haven't mentioned it before, but when I opened the rasterio images at the very beginning, here, when I open the Sentinel-2 images, I've saved a variable that was called the transform. So let me just check back where it is. Yeah. This variable. And when I opened the Sentinel-2 image, I also saved the geographical model that does the transformation between row and columns in this image. It does the conversion to latitude and longitude. So this is what we're going to use on the shoreline contour to give them longitude and latitude coordinates. So this is what I do here. We use the raster transform function with the out transform model to the shoreline coordinates for both dates. And now with GeoPandas, we're going to transform these coordinates into point objects, which will be convenient to work with. And if you want, you can uncomment those lines to save them as shapefile objects, and you will be able to open them in a software like QGIS, for example. So now to compute the distance of erosion, what we're going to do is that we will compare both of the shorelines to reference baselines that we have drawn here. We have prepared this. Those are the files are shown here. It's a shapefile. So we're going to simply compute the distance of each shoreline to the baseline and to subtract them to calculate the variation of the erosion or maybe accretion in some parts of the coastline. So with GeoPandas, there is a function that enables you to calculate the distance between objects, and we're going to cut the shoreline in this approach. So we're going to use transects. So each transect will contain several points, and we'll compute for all points the distance between the each shoreline and the baseline, and compute the average subtraction for each transect. And then for each transect, we'll have a distance of erosion computed. So here I'm computing 35 transects along the coastline. I'm also giving them I'm going back to plot the final image. I'm going back to from longitude latitudes to row and columns coordinates, still using the out transform object here. So this is the final image. So here is a 2023 state of the coast. The shoreline here is shown from 2023, and each box corresponds to a transect and is colored according to the distance of erosion or accretion in some parts with regards to the 2017 shoreline. So we can see that for the most part of the shoreline, the size of the beach has decreased, especially in this area. But here, for example, we can see that we have, on the contrary, some accretion. So this leads to the conclusion that, of course, coastal erosion is not necessarily equally distributed, even on a short location, on a small spatial scale. So we are reaching the end of this exercise. If you do this by yourself, you will have a few more exercises to do if you want to. So a few beginner level exercises where you can plot the significant wave height data at other dates or at other locations. You can also try to compute specific indicators relative to wave height. For example, you can try plotting the frequency of very high waves per month or per year. You can try to compute extreme indicator of extremes like the 99th percentile for each year, for example. So those are interesting indicators to compute. And if you are very at ease with these manipulations, you can try to perform the same analysis over a totally different location. So of course, I encourage you to do this. Okay, so thank you for your attention. And now if you have any question, I will be happy to answer them.
Thank you very much, Alexandre. Yes, there are many questions already for you.
Many?
many. Which is a good sign. So first one is a compliment. This is a great tutorial. I agree.
Thank you very much. This is appreciated.
Yeah. So is the access to the API completely free of charge?
Yes,
based on your experience, yeah. Yes, it is.
Well, I haven't have to pay for anything in this tutorial, so
no.
Everything is accessible for free. Yeah.
Exactly. You have access to all the data for free of charge, also to the API, and it will continue being like so. Great. Second one. How to add a directory of training of the tutorial, I think, on Jupyter.
I'm not sure about how it is distributed on your side.
We are sharing a document to be downloaded, so a zip file to be downloaded, and so they will have access to the Python, to the Jupyter file already, and we will be. Yeah, you probably received it via email, but we can reshare it with you as well if you haven't received it. Maybe if you've registered for the event only today, you didn't receive it because we sent it yesterday. So we can resend an email with all these resources. They will be available by email then. So next one. What product of Sentinel-2 are you using? And did you apply the corrections yourself? Then there's a comment
I
on...
didn't apply any correction. I'm using the level 2 Sentinel-2 images. So at level 2, you have already the atmospheric corrections that are performed. So you're dealing with only surface reflectance levels. But of course, the level 2 provided by Copernicus is a specific correction. And for some usage, you may have to perform other corrections, but to keep things simple, I use the correction already done by ESA in this training.
Okay, which was also accessible via WEkEO,
yes,
right?
You just have to select the level 2 Sentinel-2 products.
Okay. And next one, second question. Data recording, accuracy, for example, wave heights, are there references on the platform along with the data sets to compare studies?
I'm not sure I totally understand the questions. I mean, there are many wave data sets, if that's your questions. The one I'm using is a reanalysis, so it is assimilated with data observation and should be quite robust, but I'm not aware of
other studies,
comparative studies made for the specific data set that I've used.
No, we don't make that information available on WEkEO specifically, but if maybe we can help, you can contact us asking for those, and we can try to see if we can help you if you would need any references. Next one, what is the coast baseline shown for the erosion quantification? How did you compute it?
So I've only drawn it by hand, actually.
Would you like to share your screen?
Yes, I can do this. Sorry,
so then we can
I kind of lost myself for a second.
No worries.
Okay, I don't think I have the authorization because you're sharing the questions at the same time.
So now you will be able to.
Yes. Give me a minute. So yes, back to baseline. So this is just a line that I have drawn myself in QGIS. So I've prepared this. So this is the I saved this as this shape file here, and so for example, I can plot it for you very quickly. So here you see my QGIS, and so this is something that I've manually done. And this is not necessarily like a precisely quantified measurement, or the idea was just to have a line more or less following the coast behind the two shorelines to compute the distance difference. Because what really matters in the end is actually the interval between the two shorelines. So the reference here didn't have to be extremely precise.
So how do you compare surface wave height of satellite Sentinel-1 with surface wave height of wave model? I don't know if you needed
I've never used Sentinel-1 data, so I wouldn't be able to answer that. But I think you'd have to investigate both data sets for what corrections are applied and make sure the two measurements are comparable. But I'm not very used to Sentinel-1 data, so I wouldn't be able to help you on this one.
Okay. Is there an estimation of the wave error in height measurement? For example, how to know if 4-meter wave is an outlier or really happened?
Well, I think the dataset also provides for the error variable, which I haven't used in the training. Yeah, I don't remember actually if what exactly are the other variables, but you should be able to find it quite easily.
Oh, yes, on the viewer, you can already visualize it, maybe?
Yeah, I'm not exactly sure. I'm checking the user manual of the product that I've used, and I don't think there is actually an error variable or an uncertainty measurement.
Mm.
So yeah, I think it appears the dataset doesn't provide an error estimation.
There, okay. The next question is about if there's any issues with the performance on WEkEO Jupyter Hub. Yes, there are at the moment, not for everyone though. Some of you might be able to connect to the hub. Some of you are not able to connect. We cannot yet explain why this is happening, but we are on this issue and we're trying to solve it as quick as possible. Yes, so apologies for that, but we are trying to solve it. Is there any data available for all areas of India? Well, I don't know if you're aware of this.
I'm not aware that for
Alexandre.
Sentinel-2, you will find data for well, all around the globe, so this is not a problem.
Global, yeah.
If you're looking to work with web data, the platform we're using are essentially dedicated to Europe, so I'm not sure about India. But for Sentinel-2, you have images all over the globe, so you will be able to do this in India.
And can we apply the same coding to any other image or images? Light imagery.
I'm tempted to answer yes, because scikit image is quite common and is used for a wide variety of cases. So computing, so the extracting contours of binary images, this is doable on any image. To calculate the water index, you have to make sure that the satellite image you're using provides the necessary spectral bands that are used to discriminate water from land. But apart from that, I think you should be able to do more or less the same thing with any image.
Okay. And one last one about precision or accuracy. How precise will the results be using Sentinel-2 data? I mean, if you can say.
Yeah, well, first you have to account for the fact that with Sentinel-2, 1 pixel in those spectral bands is 10 meters by 10 meters. So there is already this to take into account.
So quite precise, you would say, or?
Yeah, it's quite good. I mean, here we've studied an area that has quite a spectacular changes, but
okay.
if
More
you
on
want
the
to monitor this
centimeter.
on an area that has probably less coastal erosion, perhaps it will cause you more trouble. But here we had a sort of an easy case to study.
Okay, so it was more evident, and so
Yeah.
10 meters is enough, is it? Okay.
Yeah.
Okay. Oh yeah, last question. Is Landsat imagery available? Not on WEkEO.
On WEkEO, I'm not sure. No, I don't think so.
No. So we provide data from the Copernicus services, and they are mainly, or at the moment we use mainly Sentinel, the Sentinel. And that's all for the questions for you. Thank you very much, Alexandre.
Thank you very much. Goodbye.
Goodbye. Now we will have a short break before we jump to Daria. Welcome back, everyone. I hope you had time to relax a little bit and that you're ready for our next exercise. I'll be Daria. Welcome, Daria. She will show us an exercise on monitoring pollution in the port areas of the Baltic Sea using QGIS.
Yes, hello. Okay, so hello everyone, my name is Daria and I work at Noveltis as a scientific engineer, and today I'm going to present you how to use WEkEO Copernicus service product in QGIS. For this workshop, this training, we're going to study, as it's coastal thematic, we're going to study pollution of the coastal areas in the Baltic Sea, as Baltic Sea assumed to be one of the most polluted seas actually in the world. Just a quick note. To study pollution, of the coastal areas, we're going to study composition of the air and composition of the water. And more precisely, well, you can study a lot of different things. You can study a lot of different chemicals and stuff if you want to have more precise, more full analysis. But we're going to stop only on two components. It's going to be nitrogen dioxide in the air. So that's basically the chemicals, this combination of chemicals, which is produced by burning fossil fuels. So, for example, in port areas, what we can notice is that we know that there are a lot of boats, a lot of ferries, a lot of cargo ships, and of course they use fossil fuels to propel to work their engines, and this cause, of course, pollution. And the second one is going to be nitrates concentration in water. So nitrates concentration, nitrates themselves it's like there are different chemicals, different substances, which by themselves can be actually beneficial. For example, they used in agriculture to make crops grow faster, bigger, better, I don't know. But at the same time, of course, as in everything, excessive amount of nitrates can be very damageful to the environment, and also including the sea environment. So we're going to study these two types of pollution. So we're going to switch straight to our QGIS. When you open a QGIS, usually it's not like this. It's usually like this. It's empty, new project. And first what we're going to do is to add this layer, which I already have, as you see. It's a Google Satellite hybrid layer, which is basically gives us our background with well, where we see the map with some countries and names and so on. A priori, you can add any layer as your background layer, of course, but we're gonna add this one because it's quite convenient for our study and basically for any studies, because you can even like zooming in, you see how map adjusting with it, which is not very important for us because we look at quite big area, but just for you for future. And to do this, we go to layer. This is add layer, and this is add X, Y, Z layer. And here, if you're new to QGIS and you don't have you never used it before, so here's probably gonna be empty for you. So what you're gonna do, you're gonna click on new. Here you can put a name, and here you can put a link to a specific layer. For example, this one, if I click on edit, this one has this link, very specific link, I know. If you want to find this link, it's going to be presented in a PDF, because this tutorial also has a PDF version, which basically has all the step-by-step instructions how to do something. So if you want to look at it later, of course you have this opportunity. And in this PDF we have this layer and some other links to some other background layers you can use, but you also can Google, for example. So when we have it, we can click OK. We can add it, load, rate. For example, I added it again, which we not gonna look at. So now as we have our background layer, it also has a coordinates reference system. It also depends on the layer. Layers different according to the layers. So what we're gonna do now, we're gonna use the Copernicus products from WEkEO platform, and I'll just show you what we're going to use. We're going to use CAMS Global Reanalysis. It's going to be, for this, we're going to use total column of nitrogen dioxide in the air. And the second product we're going to use is Baltic Sea geochemistry reanalysis, in which we're going to use nitrates. To use this data, this data is downloaded usually as a NetCDF file. It's quite common for WEkEO platform. And in QGIS, by default, there's a function to import NetCDF files, but it's not very convenient. Sometimes it misses some information. So there's a specific NetCDF to GIS plugin, which is usually empty when you open it. But for me, I already added something. So this plugin was developed by Noveltis to facilitate the access to NetCDF files. So to have this plugin, you can go to, there's a link. The link is given in a PDF and probably might be also given somewhere on a platform like WEkEO platform or platform of this workshop. I'm not sure about that, but in a PDF, it's present. So you just download it and you follow also the instructions in the PDF to know how to install it. So as we already have it, as we already installed it, we're gonna start working with our data. So here I already added our 2 NetCDF files. To add them, you can either click here and browse to your destination, or you can just, for example, if you have your like folder open, you can just drag and drop it here, which I already did. We will start with nitrate concentration in a seawater. So this one is this one. It's a Baltic biogeochemistry reanalysis. Here we actually have another one variable. Is just, for example, if you want to try something else. As this exercise is, how to say, like, it can be applied to any other type of information, any type of thematic. So you can use different products, you can use different topic with the same exercise we're gonna do right now. So we start with our nitrate concentration in seawater. For this, we go to right click, we add layers, and now we have basically all the data which is stored in this file. So here we have a depth. It was only one depth because, well, we just want to focus more or less on the surface, and 4 days. Here it's important to say that you can see that it's actually 1 date per year, and it's from 2018 to 2021. And yes, this reanalysis product, biogeochemical, was downloaded as yearly mean. So it means that, yeah, we have only like mean value of the concentration per year. You, of course, can download a monthly mean, daily mean, whatever is present there, but we're gonna stop only on that. So here, what we're gonna do, we're gonna add our layers. We're gonna add all 4 of them. Just we choose them, holding Control Shift, add and close. So now we have our 4 dates for data frames here. As you see, it's literally Baltic Sea outline. That's very, very like specific, very nicely done with like, well, with some error, of course. But so what we can do first, for example, we can play a bit and change the style of our layers. For this, we right click, we go to, oh no, wait, you can actually just double click, yeah. So for this, what we're gonna do here, you can see, for example, that on the layer, it's quite the same. We see that concentration is quite the same, which is not really, how to say, it's not very representative to us. And it's kind of true that in a, like the further away we go from the coast, the less the concentration of nitrates are, because nitrates, how we come to ocean, we come with rivers, we come with big cities, we come with ports, like, well, then we have activity, like human activity around. So of course it dissolves more and more in the ocean. So what we really want to focus on to see more of pattern closer to the coast, and for this we will need to change a bit our properties of a layer. So let's first do equal interval and only 5, so to have more or less like not too much of colors. And let's set, as I set it in a PDF, to this max and mean, and I don't know, let's use what magma, yeah, and probably inverted, yeah. So we have darker colors for bigger concentration. Tuck, I think it's good. Okay, we apply, we click OK, and now you see more specifically, you can see some nice, you see like fluctuations, some more like nice gradient. Here we see very blackish color, which means that the concentration is very high, which we also actually expect. But we will see, is this concentration is that high? Like, is it dangerous, for example? Next, we're gonna click on our layer that just changed. We're gonna go to styles, copy style, and move it to our other layers just to see with the same scale progression. For example, we see that concentration was lower in what is it in 2019 than 2018, for example. But then it got back and so on. Of course, it's not very in-depth analysis, but we can already see something coming. So Next, what we want to do is, as we're gonna see later, we're also gonna map our nitrogen dioxide in the air. And for this, we will see that our region is a bit different. For example, the areas, because it's air, it's not going to be only sea, but also like a bit of a land. So what we want to actually have the Baltic Sea region as a polygon. It's also a nice exercise for you to know how to do it, because it's basically one of the most frequent things you do in QGIS. So for this, we're gonna do conversion from raster layer, which is our layer is a raster now. You see pixels, and it's also like represented like this little icon here. We're gonna go to vector layer, which is gonna be like polygons, points, lines, and so on. For this, we go to raster, conversion, polygonize, raster to vector, which we need. So we choose any of our layers that we have, because, well, it's doesn't really matter right now because we just need a shape. And we're gonna probably, yeah, the name of the field, I think we will say. Here, you can save your result in a file. So it means that even if you close your QGIS after you save it and you close it, all the files, when you reopen it, will be back there. You see all the results you did. But if you don't save the results, don't save your like two separate files, when you reopen your project, they will be here, like will be listed here, but they won't be shown in the map because, well, we just don't have any source. So it depends. If you want to just do some quick thing and you know what you want to use it later, you don't save it to save, I don't know, memory, whatever, in place on the disk, or you want to save it, you save it. I'm not gonna save it, and I'm gonna run it. Okay, and now let me put it a bit here. So now you see that our raster layer has been modified to a vector layer, but you also can see that it got all the like the territories around, because, well, in this raster layer, it means that there's information of how to say, like area of interest. So it also polygonized it. So now we can see that it's all polygons. You can see these lines. And what we want to do now is to make it more like, let's say, readable to us, because we see all these polygons. I mean, that's all see for us, but it's not represented the same way. So what we're gonna do, we're gonna filter it to have only our ocean, the sea. And we also gonna do some operations to fix our geometries. On our vectorized layer, we right click and we go to filter. Here, we're gonna put a formula with the end because it has only one field, and more than 0. I'll click on test, and we see only water parts. So it means that all other parts which are excluded now, they are not water anymore. We are land. So we click on OK, and yeah, we can see that it's pretty good polygon. So now, as we have it here, we wanted to make one big polygon, because we see that it's consisting of a lot of different smaller polygons, and we're gonna dissolve it. But before we dissolve it, we actually need to solve our geometries, which okay, so when you go from raster to vector layer in QGIS, very often you will have some broken geometries which you won't actually see, but QGIS knows that something's wrong. So for us, we need to make sure that all the geometries are fixed, because otherwise you won't be able to do any further calculations. So for this, we go to our processing toolbox. It's this window on the right. If it's not here, there's a little like gear icon somewhere here on top, which I don't see because of Zoom blocking it, but it's somewhere there. And here we're gonna tap fix geometries. Okay, it's here. We double click. We have vectorized. Yep. Again, I'm not gonna save it. We run, close. Great, now it's fixed. It's basically the same as it was before, but as I said, like, we don't see it, but, well, there are some things that are not working well with these geometries. So now we're going to dissolve our polygons to make it one big one. And for this, think we go to this, so we can, yeah, okay, we can do this, double click up, and we have fixed geometries. Yes, we just run and close. Great. So now you see the difference that our polygons basically merged in one big one. Also, if we right click and click on open attribute table, we see basically only one field which represents our big polygon. For example, for fixed geometries, you can, if you do the same, you will see that there are many, yeah, a lot of polygons, which might hinder our further analysis. But well, now we dissolved it. Great, it works nice. Next step is again like a bit of preparatory step. We're gonna import external layer, and in QGIS you can import layers which are made by someone else. You can like Google them and find lots of information. Like people do sometimes crazy things with QGIS, and you can use them by importing it. And what we're gonna use world port index layer, which is basically a layer with which like has all the ports. I assume all ports, maybe missing something. All the ports in the world, and they are also how to say, they're classified by their size. We're going to use it because we want to see exactly like pollution over port areas. So we're going to look at the major port areas in the Baltic Sea. So for this, we're going to go to layer, add vector layer. And here you can see that you can go to some source. So we're going to go up. Nope, it's not this one. Okay, that's the folder which will be provided to you. And here you have a shapefile. We need a shapefile. It's this one. We open it, we add it, and we close. So now you can see, I'll drag it on top, a lot of small points. And if I zoom out, you see that it's all over the world. Like that's a lot of points. We're not gonna look at them, or we're gonna, yeah, our poor QGIS will die from all this information. So we will focus only on our on the Baltic Sea. But first, as I told you, it's right now it's just points. We don't know what these ports are, their size, their names. So we're gonna change it a bit by right-clicking and going to properties, or double-clicking. It was also open properties. So here you can choose style, but for this specific layer, you don't need to choose style because there's already style which being prepared by the same source. We click on style, load style, and we browse to the same folder. And here we have this QGIS layer settings file. Click on it, load style, and now you can see that all these points, it's not applied yet, so we see them as they were before. We're going to be separated in 4 different classes. So L starts for large, so the biggest one, then M it's medium, S small, and V means very small. So we're going to have these 4. We're going to click on apply. Okay, yeah, it was loading. So yeah, it's very heavy layer right now. So now you see all these different colored and different sized points, and also you will see the names of ports. So basically the names of cities it belongs to. And well, it's a lot of information. Also, we can see that it's quite heavy for QGIS to process it. So now what we're gonna do, we're gonna filter it a bit. So we don't need to, we don't need to have them all together. So we're gonna go again to filter, right click, filter, and I already prepared the formula. You can of course filter it as you want, but we're gonna just do some more or less, how to say, like approximate cropping by latitude and longitude according to our Baltic Sea. So it's like this. We put on test. Oh yes, okay. So you see now only 305 rows are chosen. Okay. Now you see the ports, all the ports in the Baltic Sea. You can also see some which are not exactly in the Baltic Sea, but well, they just got into the area of this like cropping function, let's say. That's a lot of ports. We're not going to be able to do, I mean, we can, but it will take more time. So we're going to also filter it out to only see, for example, now only to see only the biggest ports. So we're gonna remove very small and small ports just by unclicking it. You also can do it by like also filtering it out. So it's not only, for example, now we see it, we don't see it, sorry, but they are still present. So we're still like quite heavy, right? So for example, if you do some calculations, they're going to be calculated for this type of ports too. But if you want to calculate only, for example, for major ports, for large ports, you also can filter it out to have only large ports, for example. So basically that's it. We're going to also remove medium probably just to have only large ports. Okay, so that's it, our ports. So we did this little step also. And let's move to our second variable. It's nitrogen dioxide in the air. For this, we go back to our already open plugin. Hope it's here. So that's our second one, product from WEkEO platform, and it has total column nitrogen dioxide, sorry, and also this one, yes, it's a carbon monoxide. You see a total column of carbon monoxide. We're only gonna use the nitrogen dioxide. So the schema is the same, right click, add layers, and here we see that this product was actually monthly mean product. So you can see that for each month, we have a mean value. And from like 2018 to 2022, which is a lot of data. And of course, you can use them all and make a full analysis, but we don't have much time for that. You can redo it yourself. And we're gonna stick to, I guess, let's stick to first 2 years. So 2018, 2019. I'm gonna click on the first one. I'm gonna hold Control Shift till 2019, right? So it's 24. Yep. So I chose them. I would add and close. Great. I can see what's happening now. Okay, so now we see our our layer. They all added here, you see. And as I told you before, you can see that it's more like it's an area of interest covering also some of the land, which makes sense because, well, it's air, it's not water. So we have this, and for several years. And before we change the style, also to make it maybe more understandable for us, we are going to first calculate cell statistics. Cell statistics is it's a function that's like in function in QGIS, but basically what it does, it can calculate our like different statistics of raster layers, for example, mean value, maximum value, minimal value, I don't know, sum, and so on. And why we want to do it is because, well, we have our nitrates concentration in water as yearly mean. And for nitrogen dioxide, we have monthly mean, which is not really coherent. So what we're gonna do, we will see now how with QGIS, for example, if we don't have yearly mean data in the WEkEO platform or whatever other platform, how to from monthly mean have yearly mean. So for this, we go to our beloved processing toolbox and we put cell statistics. I believe should be, yes, cell statistics. Hello, okay. So that's a window how it looks like. And here you can choose input layers, and here the statistics you want to calculate. So you can see that there are several different things you can calculate. We're gonna of course go for mean, and for input layers, we need to select our layers. So we're gonna choose, of course, 12 for 2018 and 12 for 2019. So we have like all the year in one layer now. So it's a bit mixed. So it's every second one, right? Yes, should be good. Okay, it's 12 inputs, great. So we have mean, and also we need to choose a reference layer. So as a reference layer, we choose just one of the dates of our nitrogen dioxide. So for 2018, we choose the first one. Again, we can save it, maybe not. We just run. Oh, it was quite quick actually. Okay, output layer is a bit not on. Op. So now we have our mean statistics of all 12 months of 2018 with in black and white, but we'll change it later. So we're going to repeat the same thing with 2019. Pop its mean and input some. Yes. So yeah, you see, like, as you need to choose a lot of data by yourself and so on. That's why I'm not gonna do it for all our years because it will take us ages. 2019. Yes. Okay. We also run it and close. Okay, great. So now we have these mean layers, which are actually, like, if you look at concentration of nitrogen dioxide in the air, we see that, well, it doesn't really change much in these 2 years. Who knows how it changes. So what are we going to do? We, for example, we go to properties. That's not, I think, yeah, okay. So yeah, by monthly also you can see the progression, for example. Oh yeah, you can see that in why is it 2022? How did it happen? Okay, well, we don't look at this one. You can see the distribution of like fluctuation of the concentration. So what we're gonna do is just gonna copy style and again spread it to our hours paste style. So that's how it looks like now. So now we have our concentration of in the air of nitrogen dioxide. What we can do, we can also crop our raster layer according to our polygon mask which we created for Baltic Sea, to just have like this specific area, like not to be distracted by what's happening on land, for example. Well, let's see if we can do that. Well, we can. There's a function clip raster by mask, which is in raster extraction clip raster by mask layer. So as an input, we can have any of our output layers, just this one. So output layer is yearly mean. And mask layer, we have dissolved. Yes. For CRS, so coordinate reference systems, we choose the project one. And I think it should be good. Sometimes it says some parameters which better be set. Yeah, keep resolution of input. Yeah, right. And I think that should be it. Okay, let's run. So that's what we got. And this is a bit actually ugly, like this raster layer, like we see, for example, comparing to our polygon. And well, that's the explanation is very simple, is because we see that the resolution of our raster layer of our product with nitrogen dioxide in the air is quite like resolution is much worse than it was resolution for seawater values, for seawater variables. So yeah, you can see that here in 1 pixel we have like, I don't know how many, like hundreds of pixels of our layer. So of course from this to this, the polygon cutted cutted the pixels which are intersected by polygon, but this layer, these pixels weren't by its logic there. So we have this, which is not very pretty. So for other exercises, for example, you might, this is a very, very useful function and it will be helpful. Here, it doesn't really work as we wanted, so we're not going to use this result for future, and we're going to just stick to our output layers like this. And what we're going to do is we try to, for example, if we really want to see how our Baltic Sea, our polygon looks like, we're going to trick it a bit and adjust the layer properties of our polygon in order to just have a better visualization. So for that, where is it? It's this one. We're gonna put it on top, and we double click on it. We go to properties, and I think there's these things like guys, which maybe also we remove opacity a bit. Apply. Okay, great. I think it's actually working nice. So basically, we changed the style of our polygon, which is not a very scientific thing or like very, I don't know, not rocket science, but sometimes that's what you need to do, like to change different properties, different styles of your layers, just to make it more, I don't know, more understandable by you, by other users. So like this, we actually also, let's move the ports like this, probably even up. Like this, we see, for example, our ports like belonging to the basin of the Baltic Sea. So that was just quick trick, let's say. And now what we want to do, we want to evaluate a bit the concentration of the variables we loaded. So the nitrogen dioxide in the air and nitrates concentration in seawater. For this, what we want to do is we want to basically extract the values of these variables at the point of a port. So what it means that our points of a ports, they should be situated exactly on top of our raster layers. So for example, here, let's zoom in. Okay, QGIS, think a bit. Okay, so here, for example, where is our, we see that, okay, for air, we see that all of our ports gonna be intersected with raster layers because it's in the air. But the question is, are these ports, are they on top of our pixels of our raster layer of like water, seawater? Is it matching? So for that, we just, well, let's remove these guys and also this. Oh, it's a lot of layers. Yep, like this. So if we zoom to our two ports here, we see that they are actually on top of a sea, let's say. Well, as for this raster layer. So it means that here these ports for our purpose, they are situated properly. Let's look at others. Our ports. Okay, Riga, for example. Is Riga on top of water? Yes, great. So we just check it to make sure that they're all on top of. Okay, St. Petersburg is also. Yep. It's just, if it's not, then we cannot really calculate the concentrations, for example. Oh, they're all in a good place. Interesting. So maybe, oh, if all good places, it's perfect. But let me still show you what to do if, for example, we have a point which is not exactly what would be if it would be on top of a land, so it won't like register, detect what's the concentration, what's the value of a variable if it variable belongs to the sea. So for this, we can edit vector geometry. So this is our layer, which is vector layer. So we just click on it. We choose this little pencil to do editing. And now we can basically edit. We can add more points here to the layer, or we can already like edit already existing points. So that's this one, I think. Yeah. So we click on it. You see this little cursor changed. We put on this point. Okay, yeah. And for example, I move it. Well, I'll move it in the same pixel. So to now move it too much. So you see, for example, I could move it like here, which, well, I don't want to do right now, but just for you, it might be actually quite useful. So it's basically it. Nothing special. Our ports, luckily, they're all on top of water pixels. Maybe some of them are not. I'm not going to look at all of them. It's no problem. And after you did this, you just click on a pencil again. It asks you, do you want to save changes? You save it. So you have like, oh, what's happening? Oh no, it's not. Okay, let give some second. Okay, great. So now we're gonna do this extraction of our values. And for that, where are our ports? Okay, it's probably loading. Yeah, okay. For that, we go to our processing toolbox and we search for add raster values. Add raster values to features or to points. No, it's points, I think. Yeah, 2 points. Did I click on it? Yeah, okay, probably it's thinking. So, again, like as we're working with our ports layer, we choose our port layer. So what we want to do is we want to add our yearly mean concentration of what? Yeah, of nitrates and also of nitrogen dioxide, so all of them. But as we did only mean, like we calculated the yearly mean concentration for the air only for 2 years, we're gonna choose them. Wait, not this one, these two guys, and also only for like nitrates only for 18 and 19, these two. We click on OK, so we have 4 values. For resampling, I think we stick to this one. And well, again, you can save it or not. Let's run and hope it's gonna, okay. Okay, yeah, it's working, it's just a bit slow. And when we'll see. It's done, close, and we see that we have a new layer, which is still vector layer, which is called result. It's basically on the same, you see the points at the same places with our ports, and also you can see additional ones, which are actually the all the small, medium, and very small ports, which we untick here because, well, we don't want to see them, but they actually, as I said before, they're actually still in the layer, so we also calculated for them too. And as a result, we can open attribute table. And this attribute table is very big because it combines the attribute table of the initial layer with additional values. We're not going to look at all these variables, all this information, which is actually initially stored in this world port index layer. We're going to look at the last 4 ones. And in the last 4 ones, you see exactly this 4 columns means that in each of the columns, you see the variable value extracted in this point. So you see some of them are null, for example, for nitrate in the water, because, well, as I said, some of them probably are, yeah, for example, here you can see it's on top of land. So like this, we have values. What we could also done, we could, for example, filter out our port. Where's filters here? We could have also put another condition like 2 should be harbor size, I think. The harbor size equal L, I believe. Oh no, it's big L. Oh no, let's test it. Okay, it doesn't see it as a well. What if I just put it like this? Oh yeah, no. Okay, so honestly, I need to check it first. So if we go to VP, open attribute table, there is it. Okay, yeah, we have harbor size, harbor. It's actually L. Okay, well, it doesn't recognize it somehow, but we also can do that just for your information. So like this, we would only have our major large port in the Baltic Sea, which means that we won't have all these green points when we calculated our, let's look at it again, our, we didn't extract the values of the variables at the points. Here we see some values, some numbers, and to see if these concentrations are bigger or not, of course, we can go and to Google like what's the limitations imposed by government, I don't know, by European governments and so on. But the point is right now is not, is it bigger, is it smaller, whatever. Well, you can do it. It's also written in this PDF file. But the thing is to see how can we work with these values. So for this, we can open our calculator. I think it's this one. Yep. So now we have a calculator, which basically allows us to work with information which is stored in the attribute table to create new or even modify existing columns or create new columns with additional information. So we're gonna go to create a new field. We're gonna do, I don't know, for example, NO3, so nitrates for, I don't know, 2018 in, is it? Yeah, okay, let's say, I don't know, C as changed, for example. And we're gonna put some expression here. You can have some little hints on different like fields and values. For example, if you don't remember the names of fields, you always can find them here. You can have some conditionals and so on. Like there are a lot of different like functions, little things you can just blocks you can add up. And I already have a formula, which basically, let me just check it. It converts our nitrates concentration from let me see. Yes, from microgram per cubic meter to milligrams per liter. I think maybe I actually read wrong line. Yeah, I think it should be good. So we just put this formula, but this one is actually not the name we need. We go to the names. Where was it? Field and values. So we need the last one. Yes, exactly this one. So we do this. We already actually see here like a preview, a number, and for feature. For example, this is for this exact port Baltisk, and you can choose like others. For example, you see that this one is in the ground. That's why it's null. That's for some other one. So we click on OK, and now we have, oopsie, and now we have our additional layer. No, sorry, not layer. Column in this layer with a value which is actually, I guess, been its format changed, so we don't see the, it's not a float, it's an integer now. Because I think when I was doing the output, when I was creating new field, I didn't, yeah, okay, for example, here, if we open field calculator, you see here I put outfield field type whole number integer, so it gives us, it's like rounds to the integer. If I should have chosen the this one decimal number, it would be just a bit different. So basically that's it. And here we can adjust the data we have, like you can have like you can add other columns with whatever you want, and then after you can also filter. For example, if we know that I don't know, this concentration shouldn't be more than 10, you could also use this filter function which you already used to say like show me only the ports in which this concentration, this specific variable is more than 10, so to know where the concentration is more than the norm, for example. So that's basically it. It was quite short and I don't know, maybe easy things to show. But yeah, we learned how to basically work with both type layers types in QGIS. It's vector and raster, the principal ones, and yeah, how to switch between them, how to work with additional layers, external layers, how to fix geometries, and also how to extract values. So yeah, you can like go. You may can do the same analysis with all the dates, with different other variables to extract their concentrations and like check with I don't know, European guidelines and to see if these norms are the norms are exceeded or not. So yeah, that's it.
Thank you, Daria. No, it was, I didn't find it short. I found it quite complete, quite complete, quite full of detail. I mean, for people who are not so much used to QGIS, will probably need to re-see this session, but this is great. This is recorded, so they will be able to follow you, hear you once again. Thank you. And yeah, we have a few questions for you. The first one is actually about, so how you search, so what is the source of the world sports shape file? I don't know if it is easy for you to show that.
Yeah, well, the source is it's in a PDF. It's done, given. I can just read you out this. Yeah, it's provided by Maritime Safety Information website, and yes, it's made available by the National Geospatial Intelligence Agency.
Okay.
If it tells something, but yeah.
This was you got this information because you selected that source yourself, or
it's just some source, as I said, like very often you would for your study, you would go between different sources, between some, especially like vector layers. For example, most of the data that you can find on WEkEO platform, there's mostly raster or satellites images, which also raster. So if you want some polygons of like, I don't know, country borders or like major cities or something, you just go to, I don't know, to Google and you put world country borders shapefile and it gives you.
Yeah,
Well,
okay.
just better, yeah, like stick to some more like governmental, more like trustworthy sources. But yeah, there are also a lot of people who do things like this by themselves just for fun.
Oh, we could share it maybe
Yeah.
on a GitHub or something. Okay. Thank you. And the second one, what is the criteria for classification in LMS and V harbors?
Okay, so this was a classification provided by the same source, by the source from which the layer is made available. And the size, I think, is according to the size of the city which it belongs to. So the cities, I don't know, like less than, I don't know, 100,000 people, it's probably like small or whatever. Like you also might notice that during tutorial, we chose only large, we were depicting only large ports, and you could see that it was basically like Helsinki, Tallinn, Stockholm, Riga, so basically capitals or some very major cities on the Baltic Sea. So it's the population, it's the size of a city which hosting the port.
Yeah. Was it just here? Did you selected those cities because you wanted to make sure that there was a big concentration of nutrients,
Exactly.
for example? Or?
Yeah, and also because, well, we saw that it's a lot of ports like on this layer, and it also might be a bit like confusing, overwhelming to see too much information, too much names and stuff. That's it. You can do with whatever you want, basically.
So next one is not so much of a question, but more like a comment. So a while ago, I tested the CMEMS QGIS plugin. There was a mistake about your referencing. I don't know if this is the latest version though, because actually the plugin was updated maybe 2-3 weeks ago. And so maybe you could try to download the latest version and see if this still occurs. If it still occurs, you can let us know, the user support, and we'll look into it.
Yeah, it also might depend on a product you use. For example, I know that sometimes it happens that, for example, even if you read the attributes, the properties of some product, it tells you, I don't know, for example, some specific coordinate reference system, and then you open it in QGIS, it's a bit different or completely different. So this happens, and yeah, sometimes it's might be corrupted file. Maybe when you download it, something happened. So yeah, it's.
So it could still be present in the latest version, for example, right? Could still be
Yeah,
dependent on
it might be even present if you open it without the plugin, for example, or if you open other, like through just, or just with like raster layer, which you just like drag and drop with like satellite data. It might be just bad georeferencing or
okay. Yeah, so maybe the easiest is if you still encounter this problem, just let us know. We'll try to help you. And another one, is it possible to assign raster values to a polygon instead of a point? I assume it would be the mean of all pixels inside that polygon.
Okay, so there is a function we use. It was add raster values to point, I think. There's another one which called to features. I think I can check very quickly. Yes, it is the same in the same toolbox section, let's say. There's also add raster values to features. So instead of points, you can also use polygons, yes. How does it work? I don't know, never used it, but I assume that, yeah, it would probably do some maybe like a mean value of all the like values that are included in the polygon. Yeah,
makes sense.
Yeah,
it
I think
sounds
so.
logical,
Yeah,
but yeah,
probably maybe we're also maybe there's a function like when you choose to assign it to not to point to polygon, maybe you can also choose the method it assigned to min or to max. It would make sense to choose min though, but who knows? I mean, QGIS is it has a lot of various features
Different
and tools,
options.
which are, yeah, like it's a lot to dig in.
Yeah, definitely. I think that's all for you.
Great.
Yeah, and we have a little comment. Thanks, Daria.
Well, thank you.
Thank you. I agree. It was a nice presentation. And yeah, we are reaching the end of this practical session. I hope you enjoyed it. I hope it was insightful. I hope we could give you information you didn't know yet. And I hope you enjoyed these exercises. And don't hesitate if you have any questions to contact the user support as usual. And yes, once we finish this webinar, there's a little survey it will be open on your browser. It will help us a lot if you could fill it in. It takes a few seconds, and that can help us to, I don't know, improve next sessions, know what you're looking for, and yeah, that's it. Thank you all for your participation, David, Alexandre, and Daria. Thanks a lot for another session, and I see you next time. Have a good day, everyone.